Welcome to Devices Part 4. So in the previous video, we started to work on a example where we were adding a washer device into the system, and we got through the global declaration. We added the variable to the devices list globally, and then we actually worked on IO mapping some of the inputs and outputs we were going to use for our device in the physical Ethernet IP device, and we showed how to do that. And then we were just got to the point where we copied the device function block template, and we were getting ready to instantiate that device function block in our robot um, function block. So again, our robot is the parent. So we want to instantiate the function block inside of our parent. So if we come back to our code assist code here, I think it's always helpful to kind of just come and show you how I navigate through. So source, um, robot, and then robot function block. So it's already open here, but in a robot function block, you want to come all the way to the bottom. And this is where your child devices will be defined. Down here, child devices. So debur. So you got our old washer function block. So we want to actually delete that, and we want to, where was that located? Okay, right there. So we want to delete that and then add it in over here. And so the way we do that is POUs. Sorry, the way we do that is come down to POUs, and then we look for, they organize this POU by how most recently did you create it. So older ones are at the top, fresh, newly created, newly defined function blocks are at the bottom. So this wash function block is at the bottom. So I'm going to add that in here, right there. And so at this point, basically just want to copy the name of the function block itself and give it a lowercase letter, and then we must define our child devices. So inside of the robot function block, there's a section down here for child devices, and we have a couple places that we wanted to add. So we wanted to add a reference. We'll come back and add that reference here. We want to instantiate this wash function block. So we want to do wash function block of type wash function block. Okay, so that should satisfy that. If I hit Control Save, the red squigglies should go away. And then down here, we basically needed to define the device or pass it in the device data. So it's saying it does not recognize wash. Do I want to create a new variable? The answer is yes, but I want to do it my way. So I want to actually create a reference to wash. So reference to device. So the wash is a device data type, and we want to assign it, have it point to the device that we declared in main. And so this is kind of a way that we locally alias a data type to another data type, in this case main. So there we go. So what this is saying is our local variable wash that we're going to use in here is we're actually using this main.wash, and there's really no harm in using main.wash. It's just a little bit longer, so I'm doing it this way to just make it look a little bit cleaner, but I kind of mix how I did that in the code, so mostly I'm just trying to keep it consistent with how I do everything else that's similar. So like the deburr, I'm just going to keep things consistent. So the next step that we'll have to accomplish is adding in pointing to our data types here. So we've got the parent ID, which we can just say dev.config.id, and that basically what that's saying is dev.config.ids. Dev is, in this case, is the robot device, and its configuration data type, its ID. So we're going to pass that into the wash function block as the wash function block's device parent ID. The wash ID itself is going to be device IDs.wash. And then part data is part data. What's wrong? Why are you yelling at me? No, it's okay. Okay, so part data is kind of a global variable. It's used, it's a pretty big data chunk, so lots of devices are using this part data. And the part data itself is discretized by, well, it's not necessarily device specific, but it tends to be device specific. So again, if we come into our wash function block, so well, before we get there, so we're going to customize our wash function block, but before we do that, there's a few other things that we have to do within our parent to define the child. So we saw we already added, we appropriately added the function block, the device data type, and we can also create a reference to the handshakes as well. So I could say wash handshake reference to wash handshakes, and then assign it to main.wash hs. And then we'd have to declare wash handshakes inside of our wash function block, and we basically pass that variable in here on the outside. The last thing that we need to do, the child array. So this child array is the children of robot is defined in this array. You've got the FANUC robot controller. We've already got our wash device in here. Remember, I kind of already had this device ID in here. If I didn't, I could just add it and say it looked something like this. And let's say there was a 0 there. I would just come in and get rid of the 0 and add it in like this. And so basically what all this is doing is just telling the robot, okay, these are all your children, and that's how I'm collecting that. Okay, that pretty much handles the instantiation within the parent device. Other than that, we can now go in and actually customize our wash function block. So again, this was copied code that I pulled from packages. All I did was come in here and I copied packages device template function block, pasted it down in here. I created a wash folder, and I just pasted it into this folder, and now it's this wash function block folder. This data type, this function block is now defined here, and so we can double click it here. We can also go to, I'm going to close all these editors. if you go to robot function block, we scroll all the way to the bottom, near the bottom, and we look at wash function block, we can just double click on that and boom, it opens it up for us. So we can see inside of this template that it wants us to, I basically already like provide all of the stock kind of variable declarations, and I comment out places where you could likely add in variable declarations. So for us, device data, you could uncomment that, type in wash data, reference to wash data type, and point it to main.wash data. So again, that's going to allow us to use that global scope wash data variable. What's wrong? Just got to hit save. Sometimes the red squigglies don't go away until you hit save. So that's an internal variable. You see var and var, so that's internal. So we won't see that indicated here on the outside. But let's say we wanted to add in our handshake. So here, add in wash handshakes. And once we go to robot, we now see it doesn't like this. So var in out handshake must be assigned in the call of wash function block. So it's upset. So you got to update parameters. Then here you would actually assign it wash handshake. You know, again, we created that in the robot, in this robot function block right here. So we created a variable. It's actually a reference to a main variable, but we plopped it into here. So one thing I want to do is look at, so there you can affect the order of how you assign, like how this is listed by changing the order in which you declare them, and I want to just keep things consistent. So I want to go to my conductor. Actually, I want to see how I'm doing it for the robot. So if we go to conductor, we go to the children down at the bottom. The child devices all have handshake following part data. So I want to keep that consistent. So if I go back into robot and look at debur, I see my handshake is actually listed here. I want to put that at least down here. So I'm going to go into debur function block, and I'm actually going to, so this is how you have to do it. I'm going to copy that. I'm going to delete it there. And I'm going to keep this in this order. These internal variables, it doesn't matter. Basically, it'll skip over that. Input, I want to put it after this child ID, so I have to create a new block for a variable type in out and add it in there. So if I go back to my robot function block and I click update parameters, it should flop that around. Okay, but look what it didn't do. It didn't switch my data, so I'm going to have to put that there, put that there. Oh yeah, debur is kind of an old, it's an old one. So child ID, I actually changed the name to just ID. So it's kind of, you know, refactoring code. You gotta do it everywhere sometimes after you make a change. So update these parameters. Device IDs.debur. Okay, boom. All right, now that looks kosher. I like it. So coming back to our washer function block, we have given it all the variables from the outside world. Probably asking why are some variables var in out and why are some inputs. Var in out allows you to create an implicit reference to a data type, so it's not copying a data chunk from one data to the next. It's basically just creating a reference to it. So we could also not have any variables on the outside and have them all internal, and then we could create a reference inside of here to the variables out here. But this is just one nice thing about maybe putting variables on the outside of a function block is you can kind of directly see like what are the pertinent variables that are going in and out of the function block. So it just kind of gives the control developer, the software developer, it kind of gives them an idea of what's being passed in and out of that wash function block. It's probably better practice to do that rather than doing a bunch of internal variables that are references. It probably helps with tracing data, but I think for some reason I don't know if maybe I got lazy perhaps, or I didn't want this function block to be 12, 15 lines long, so I decided I only wanted a few of these pieces of data on the outside. So what we basically need to do right now is we need to customize the logic within our wash function block to do what we actually want it to do. So the first thing that we need to determine before we kind of attack the actual stepwise logic is we need to come in and finish defining our variable data type. So these are our variable declarations. We added a reference to this wash data. We really don't need part data, so I'm gonna actually get rid of that. So child devices. So the wash doesn't have any children devices, so this can basically stay as is. If the wash did have a child, you'd add it in here. We've already seen how the robot did that, so for us, for the child array, we're just going to keep this empty. So it should be 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it needs to match whatever that value is, 10. So this array has 10 indexes. I don't need to do anything here. Inputs and outputs. So we want to do a reference to wash inputs, inputs.wash. So this is going to be a reference to that global variable, a true global variable here, inputs. So inputs.wash. Remember, inputs has this wash data type. Same thing with our output, reference to wash outputs, outputs.wash. So now, when I type in o dot, let me hit save real quick. I'll say fake bool equals, I'm just giving you an example and showing you. Boom. So all the outputs associated with the wash mechanism are now just defined here. So I can choose that. All right, so that is basically the end of declaring our variables, customizing our variable declaration per our new device. So again, typically for a new device, you're going to have inputs and outputs. You're going to have a custom handshake, perhaps. You're going to have custom data, perhaps. And then eventually, if you determine it has children, then you would update that to reflect, you add your child function blocks, add a reference to the child device, and then reference the children in this array for your child array. So don't need to do that here. So now we're actually ready to start coming in here and hacking away at this code. So we've got all of our primary states and step numbers in here. So all we really need to do is fill in a couple extra steps for this washing device and we're done. So basically for our wash device, it really currently it just really consists of those 4 outputs that we looked at. So you've got, at some point, we're basically just controlling these outputs on and off. And, while the washer is inactive, killed, or idle, we really don't want those outputs to be on. So we need to write the logic to make sure they're not on. And then we want to basically allow someone to request the washer to, we can either have them do a start command. So in a start command, basically it would be equivalent to us just turning the blowers on. But if we had more of a complex sequence, we could have, use our hand shaking, and we could say, dunk first and then wash and then blow dry. But the way that we're doing it now, basically, we just issue a start command to the wash, and then the wash transitions from idle to a running state. And the running state, it is activating those outputs for the dryer. And then when we drop our start command, it just goes back to, basically goes to a stopping step. And stopping step, we just verify that all the outputs are off, and then we transition back to idle. So that's basically how we want to write this logic. So if we come to our state machine, so this device state mechanism, and all of these states here, faulted, killed, inactive, resetting, idle, we want to make sure that our 4 outputs, we have these dryer outputs. We want to make sure they're not on. So the only time we really want them to be on is inside of this running step. So someone gives us a start command, and when we transition from idle to running, that's when we set those outputs on. And then when someone drops the start command, then we transition to a stopping step, and then we verify that those outputs are off, and then we slingshot back to idle. So pretty simple logic that we're going to be putting in place. We'll never really use this done task because our current wash device does not really have a process. It just really has those dryers. And again, the robot is ultimately going to be requesting the start command. The robot's basically requesting the blowers to be on. So from the robot parent into here, it'll be issuing the start command. It'll turn the dryers on and return to idle. So let's make sure our code reflects that. Now I want to show you what the old code looked like first, before we detail this out. But actually, I don't really care. You can just see the old code is like 2 rungs long, and yeah, it was basically, yeah, it's a very simple mechanism, right? It's just outputs on and off. But this is those are the outputs we were setting. So we're gonna reuse these back in our program. Let's go to wash. So those wash output valves, I know that they're connected to the SMC uh, the SMC valve bank. In that SMC valve bank, those solenoids are dead when the e-stop circuit is dead. So the control power to the solenoids is dead when the e-stop circuit is broken. So it's a good idea for us to include this instant kill reaction logic whenever the e-stop circuit is broken, or whenever we get a kill command. So this logic holds up. We've got a reset command here as well, which would react to a reset. If we issue a reset while we're in idle, it would just slingshot back to the resetting routine, which doesn't do much in this device. We can leave that in here. Instant stop if there's any errors present in this step, then we would we could issue an instant stop, which would basically take us from whatever step we are in running to stopping. And generally we can assume that we can do that if there's ever any errors present, or if our children ever have any errors present. So it's like kind of a catch-all. And then this instant manual, currently I have it disabled, and I'm going to leave it disabled because right now I don't have any manual mode logic for that. But yeah, basically this always off will never be true, and this will never be on, and this will never activate. So don't need to do anything here. By using these dev and eng device variable names, or it's generic. So all the function blocks, whether it's debur, robot, they all have that same data type. So it's really easy to copy paste, really easy for us to copy paste into this. We don't have to do much reorganization or reset up. So device inputs, executor engine. So the first true step we have here is this faulted step. Again, if there aren't any errors, we're going to allow this transition to inactive. That still holds up. In the killed step, if we're not actively in an instant kill and we're not getting a command to be killed, then if we don't have any errors, we'll transition to inactive, and if we do, we'll transition to faulted. So in an inactive state, we're waiting for a reset, and as long as we don't have any errors, we'll transition to resetting. If we do have errors, we'll transition to faulted. So all this logic still holds up. So we just keep cruising through. So in our resetting step, sometimes you would initialize some variables and do some things. Well, for us, we don't need to really do anything. So we're just going to run through this, allow it to transition to step 60. Step 60, it's just stock logic. It allows you to create some custom logic to reset yourself. We'll just allow this to slingshot through and come to idle. So basically our resetting doesn't really do much, but it's in there anyways. One thing to note is that anytime there's errors present, I would jump to an aborting step rather than a stopping step. So stopping I kind of reserve for when we're either idle, paused, or running. Aborting will just make sure we basically kill ourselves. So I'm going to run down, show us our idle. So in idle, right out of the gate, we have this, we're waiting for the start command, which will come from our parent. So when we start, we would transition to this running step. So in this running step, we need to add our logic to set those outputs on and off. So what we basically just need to do is call output dot blow one off, control C, control V, control V, control V. And so basically we just get all of these in here. Okay, that simple. So we're going to sit in here. The other thing that we're going to want to do is we're going to want to add in we want to ignore our timeout. So we want to do that with this move command. So we're going to move, if we set this value to 0 seconds, we do eng.step timeout. So this is basically going to ignore that timeout. So we won't time out in this running step because it takes kind of a long time. If we didn't put this block here and we stayed in this, and we were in this step for 5 seconds or longer, we would trigger an error. The device state engine would trigger an error, and then we would go through a faulted, stopping to aborting to kill to faulted sequence. But since we need to stay here longer than 5 seconds, I'm just going to ignore that warning altogether. And I'll still leave in this transition logic to say, okay, if there's no errors present and there's no start command, so dev.commands.start. So if someone's not wanting to run us anymore, then we'll just go back to in this case, let's actually just go to idle. So really, we're not ever going to done. We're not really ever doing anything worth going to done for. So in this case, we're just turning these on and off. I think I actually did say we were going to go to stopping. So let me do that instead. So for stopping, basically, if we come down here in our stopping logic, for stopping complete, I want to verify that all those outputs are in fact off. Okay, so what this is saying is that it's not going to transition out of the stopping until it verifies all these are off. Set that bit on. This is like an OTE in Rockwell, but basically the only place that we're setting those on, this is OTE, is here. So if we're never in this rung, these are always going to be off, but it's just good practice anyways to put it here. Alternatively, someone could do like a set rather than doing an OTE, and that would just set that output on, and then you'd have to physically reset it in another step. But since we're just doing the OTE style, it simplifies a lot of our reset logic and a lot of our stopping logic. And that's why I'm a huge fan of using OTEs. It definitely simplifies some of those resetting tasks. So, yeah, in our stopping, verifying all our outputs off, stopping complete. Once we're stopped complete, if we have errors, we'll jump to aborting. If we don't, we'll jump back to idle. So that is effectively our code for this device. I am going to open up the old logic here, and you can see here in the old logic, I guess I had a timeout of 120 seconds as opposed to ignoring it altogether. Oh, well, here. So in my old logic, I actually had this dryer blowers are on status. So I'm going to copy those. Don't have a lot of confidence that this is going to do what I want it to do when I hit Control V. Yeah, it just does something really goofy for some reason. That's okay. I like doing this. There we go. There we go. Look at that. OTE. Wash data. Drive blowers on. Now I could probably shake this logic here. You know, might be a better practice to actually move this to something called a monitor. So if we come down in here to our monitors logic. Let's see. If I hit Control V, OTE. This is sometimes better practice, and in case you are running some manual mode tasks where you're setting those outputs on, your washer data, still active or still working properly in multiple cases. So since we added it there, we got to delete that OTE here. Okay. And I'm guessing that we're using this status bit in our robot, in the robot function block. So we'll look at that. Let's go back and compare the old code again. So we had that status bit, and yeah, that's pretty much it. So that was the old code to do replace this logic with a device template. Hey, guess what? We did that. So we can delete this puppy out of our logic. So at this point, we should be able to run similarly to how we did in the past. So let's just go into the robot function block and see how we're calling and using this data. So I know for a fact the robot. So the robot starts out in idle, and then it jumps to this. Sorry, my autosave just jumped us. So idle, jump to step 200, and we jump to task branching, and if we're a wash and dry task, step 220, step 220. Let's look and see what's happening. So we've got this step timeout to 2 minutes. Set our task ID to the robot controller. So we are waiting for this drawer blower request, and that's coming from the FANUC robot controller logic. So the teach pendant program is going to set that bit for us, and once we detect it, we are going to set this wash commands start. So this bit actually, I'm guessing it maps to our wash.commands.start, and we'll chase this down in a second. So yeah, basically we're going to just react and start that washer whenever this request bit comes in from the FANUC, and then once that's all done, we're going to wait for the washer to be idle, the FANUC to be done, and then this is going to transition out of this step and do some finishing moves. So I know we're using that wash data. We talked about that wash data status bit. I know for a fact we're using it in the. If we actually go to the FANUC controller, if we actually go to the FANUC controller function block, we have this thing called the FANUC 30 IP map. I believe this is where I'm mapping it to a output to the FANUC controller. So I'm giving the robot the status. The wash is running. So it actually is better if we do it like this. We go main dot wash data dot dryer blowers are on. Let's do it like that instead. Because DI4 is really looking for it's looking for that dryer status, that those dryer blowers are on status. So this is probably a better way to do that. And so I'm going to leave this logic in here like that. Again, if we come back and we go to our running step, so when we're in this running step, that running bit that I just deleted and replaced in the IO map, that would have been on. So instead, I am just using that wash data status bit, and again, that's coming on whenever all 4 of these blowers are on. We're setting that wash blower dryers are on. So I think that is it. Robot function block. Yep. Okay, so we were going to look at this. So I'm guessing if we come down to the bottom, I usually collect some of these outputs. And this wash command start. Yeah, I have 2 places where I'm actually starting this washer. So I know in our auto recovery sequence, we potentially use it. So that's why it's in step 50. That's the resetting step for the robot. And then I also have it in that step 220. So again, I'm using an OTE. When we're not in either step 50 or 220, then this start command isn't on. It just aids in the logic that we need for resetting and initializing data. Some controls engineers prefer to use set and reset, and they hate OTEs, but I love them. I think it's really easy to just map if you want to use if you want to be able to call this start command in multiple places, we'll just add another OTE and just map it here. So it's really not hard. But the wash command, basically when that comes on, again, we're going to transition from idle. We're going to transition from idle into running. In running, we're going to turn those blowers on, and we're going to sit there. Gosh, autosave jumps you around. So we're going to turn those blowers on, and we're going to sit there until this start command is dropped, and we're going to transition to stopping. Alternatively, if we wanted to just be completely thorough, we could do, if someone issued us a stop command for whatever reason, we could also just directly issue it right there as well. But doesn't really matter. That's not going to be the case. I'm not ever calling stop command anywhere, but so I'll just delete that for now. So if we drop the start, if the robot drops the start request, then we're going to stop. Basically, we're just verifying that those outputs turn off, and they will. And once they do, then we'll transition back to idle, and you'll see in the robot logic that in step 220, it's depending on wash is idle in order to transition to this finishing step 290, which is basically checking the robot end position. It's a step we use to verify the robot ended in a way that we expected it to end a task. So that was basically adding the wash function block. Yeah, hopefully that was all crystal clear. And yeah, I think with that, I'm going to sign off.